Welcome to the third video of the derivative series. In this video we will learn the product and quotient rules and solve instructive examples. Without further ado, let's get started. Here guys, as we see, if we have something f of x as u times v, where u and v are differentiable at x, and these are the functions also depending on x. In that case, if you take the derivative of f function, then the result is going to be equal to the derivative of the first term, which is u. Okay, suppose that u is the first term and the v is the second term. So the derivative of the first term times the second term plus the derivative of the second term times the first term. Derivative of the first term, u prime, also can be written as du divided by dx. And similarly, the derivative of the v can be written as dv divided by dx also. When it comes to dividing, guys, for example, if we have f of x as u divided by v, which is the second case that we have here, then the derivative of f of x can be written as u prime times v minus v prime times u divided by the square of v. I know that when you look at all of those terms, it may look like a little bit complicated, but once you solve questions, guys, then they're gonna start making more sense. And let's take a look at some examples. We have u of x as 2x plus 1 and v of x as x squared plus 2. And then in this case, what is the derivative of u times v, let's say. So the derivative of u times v, let's call this as f prime, guys, okay? Or it doesn't matter, we can just write u times v derivative is equal to, guys, the formula is also here, so it's going to be u prime times v plus v prime times u. I recommend you to memorize this, by the way, which is going to help you a lot to grasp the topic, of course. And this is going to be equal to, so it's going to be 2x plus 1 prime times x squared plus 2 plus x squared plus 2 prime times 2x plus 1 also, guys. So the derivative of 2x plus 1 is going to be just 2, right? 2 times, in parentheses, we have x squared plus 2 plus the derivative of x squared plus 2. 2 is constant, so we're going to have from x squared just 2x. So 2x times 2x plus 1, guys. And that is equal to, if you distribute 2 into the parentheses here, then we're going to have 2x squared plus 2 times 2 is 4 plus 2x times 2x is going to be 4x squared plus 2x times 1, which is 2x, guys. If you add the like terms, for example, we have here 2x squared and we have here 4x squared, which is going to make it 6x squared plus we have 2x here also, 2x plus, and as a constant we have 4, guys. And that is the result of u times v prime. And as a second example, guys, we have f of x as 3x minus 6 divided by x plus 2. And in this case, what is f prime of x? Which means that, guys, if you think the numerator as u and then denominator as v, okay, so it looks like u divided by v, and then we can go from there. So I'm going to just directly apply the formula here, guys. F prime of x is the derivative of, let me write the functions first, guys. So we're going to have 3x minus 6 prime times the second term, which is x plus 2, minus the derivative of the second term, which is x plus 2 prime times the first term, 3x minus 6 divided by x plus 2 square, guys. And this is going to be equal to the derivative of 3x minus 6 is 3, guys. By the way, before starting, let me put here the line. So we're going to have 3 from here times x plus 2 minus the derivative of x plus 2, which is 1. So I'm going to directly write 3x minus 6 and divided by x plus 2 square, and that is equal to, guys, if you distribute this 3 into the parentheses, then we're going to have 3x plus 6 minus 3x plus 6, guys, here that minus is going to be positive. And in the denominator we have x plus 2 to the power of 2. Those three x values are gone, so we have 12 in the numerator. So f prime of x can be written as 12 divided by x plus 2 square, guys. And this is our last question, guys, in this video. We have a slightly different question. F of x is given to us as ax divided by x plus 2. We can treat the numerator as u and the denominator as v. And in this case, f prime of 0 is given us as 3. And what is the value of a? We don't know a here. So I'm going to basically apply the derivative formula. So f prime of x is equal to, guys, again, I'm going to treat the numerator as a first term and denominator as a second term as u and v. So the derivative of ax is just a, right? So a times x plus 2 minus the derivative of x plus 2, which is 1, right? 1 times ax is going to be just ax divided by x plus 2 square, guys. And this information is given to us already, so we know that f prime of 0 is 3. That means, guys, in this function, if we put 0 instead of x, then the result is 3. So let's apply it here. F prime of, I'm going to put 0 instead of x. And this is going to be equal to, guys, if you distribute, by the way, this a into the parentheses, then we're going to have, let me actually rewrite it here. We're going to have ax plus 2a minus ax divided by x plus 2 square, and still this is equal to f prime of x. And here, if you see, we have ax, and those are gone, so we have 2a plus 2a divided by x plus 2 square. So here, guys, if you put 0 instead of x, then we're going to have still 2a in numerator, and in denominator we're going to have 0 plus 2, which is 2, right? So it's going to be 0 plus 2 square, and this is equal to 3. I'm using this information, guys, here. So here, guys, we have 2a divided by 4, and that is 3. Here we can write 1 under 3, and then we can apply cross multiplication here, and then in this case we have 2a times 1, which is 2a, is equal to 3 times 4, which is 12, guys. If we divide both sides by 2, then these are gone and a is alone, so a is, guys, 12 divided by 2, which is 6. That means a should be 6 in this case, guys. And this is the last question in this video. If you have any question, you can put them in the comment section below. Thank you for watching, and hopefully see you in the next video.